dear students. Today we talk about topic number 14, Basics of the Oncology, the lecturer Shevchenko Alexander, Baltic Federal University, Medical Institute, Kaliningrad, 2020. First of all, we must talk about terminology, which will help you in further education of oncology or surgery. Because if you didn't know the basics of terminology, you cannot understand about what we will talk further. So, oncology, it is the science involved in the study of prevention, diagnosis and treatment of cancer. But frankly speaking, not only cancer. You must understand, what does it mean, cancer? Cancer is a malignant tumor which grow from the epithelial tissue, but we have different types of tissue which can grow into the malignant tumors. So, what is a tumor? Tumor is pathogenic growth of tissue which can grow due to the multiplication of its cells and tissues. Here, for example, we see two tumors in the human brain. Tumor can be benign or malignant. You must divide it strictly because benign tumor cannot be the cause of death. We have one exclusion from this rule. It is benign tumor which placed in the brain. When benign tumor placed in the brain, it can compress the human brain and we have death of the patient. What is the features of benign tumor and why we divide it from malignant tumor? Benign tumor doesn't invade into surrounding tissues. It has not so fast growth rate like a malignant tumor, and it didn't metastasize. And malignant tumor have all these features. It metastasizes, invade into surrounding tissues and have more high growth rate. On the left picture we see lipoma. Lipoma, it means benign tumor which grow from the adipose tissues. You must understand, if you see any name of the disease, any name of the dissected part of the human body, and on the end of this word which describes this part, you see oma. Oma from Latin means tumor. So if you see ending of the words oma, you must understand this may be the part of the science of oncology. So go next. A benign tumor is a mass of cells that lacks the ability to easily invade neighboring tissue or metastasize. When removed, benign tumors usually do not grow back. So here on the picture we see benign tumor, and which specific features do we see here? It's packed in the capsule. It didn't invade into surrounding tissue. We didn't see that it has any metastasis here. It's surrounded by normal blue cells, like it pictured here. Any subject have its goals. So, goals of oncology is to study of pathology and pathogenesis. Second, development and application of modern diagnosis methods. Third, improving treatment methods. And fourth, development of methods for prevention of malignant tumors. Cancer. Cancer cells are cells that divide relentlessly, forming solid tumors or flood the blood with abnormal cells. As I say previously, cancer, it is malignant tumor which form from epithelial tissue. You must remember it. Any malignant tumor have its biological features. First, self-sufficiency of growth signals. Second, insensitivity to growth inhibitory signals. Third, invasion of apoptosis. Fourth, potential for limitless replication. Fifth, angiogenesis. Sixth, invasion. 7. Metastasis. 8. Reprogramming of energy metabolism. And 9. Evading immune destruction. First of all, self-sufficiency of growth signals. Any cell in our body takes signals from surrounding tissues, from hormones, from chemical compounds surrounding it, and from these surrounding compounds, hormones, and another cells. Any cell in our body have growth signals to grow it or to inhibit its own growth. So it doesn't really feature of the malignant tumor. It is self-sufficient. It haven't such receptors or haven't too much of this receptor, and any little impulse grow into the high growth signal. Second, insensitivity to growth inhibitory signals. So we have such compound, for example, which called tumor necrosis factor, and when it's connect to the receptor, growth rate of the normal cell is inhibited, so it's not divided. Third, evasion of apoptosis. You must remember that apoptosis, it is programmed cell death, so it doesn't the feature of the malignant tumor. From first and second points here, we have potential for limitless replication, because if we have self-sufficient cell which insensitivity to growth inhibitory signals and evasion of apoptosis, it is logically that it have potential for limitless replication. Any cell needs its energy, and energy supply for most of all tissues in our body provides via vessels. So angiogenesis is important factor, and malignant tumors have more vessels than normal tissue. 6. Invasion. Invasion means that malignant tumor can invade into the surrounding tissues. Metastasis is going from invasion, because when malignant tumor grow into the surrounding tissues, sometimes they grow into the lumen of the vessels, and some part of this malignant tumor is self-sustained into the lumen of the blood vessels, and with the flow of the blood into this vessel, it goes further to another part of the patient body. 8. Reprogramming of energy metabolism. It's important because when we have cells which self-sufficient of growth signals, which have limitless potential for replications, it logically to assume that this cell have another mechanism of energy metabolism. And 9, one of the most important factors, it's evading immune destruction. Why it is more important? Because every second in our body, from different factors, we can assume we have thousands of cells which can be malignant tumors in another condition. But when our immune system is working, these malignant cells, future malignant tumors, is destroyed by immune system. In further lecture we will talk about transplant surgery and about transplantology at all. And what I wanted to say, when we transplant some organ to a recipient, we must inhibit a recipient's immune system. And one of the complications of the transplant of the organ, it is growth of the malignant tumors in the patient body, because the immune system didn't work properly. So, factors determining tumor growth rate. First is proliferating pool size, second, size of dead cells, and third, cells proliferation rate in a population. If we talk specifically about breast cancer, we have Ka67 protein, also known as MKA67, is a cellular marker for proliferation. In breast cancer, Ka67 identifies a high proliferative subset of patients with ER-positive breast cancer. ER means estrogen. So it is very important to understand how fast this tumor grows. We have 5 general types of growth rate. We have 5 growth types, different. First of all, invasive, second, expansive, third, oppositional, fourth, on or multicentric, 5, endo or exophytic. First of all, invasive. With infiltrating growth, the tumor cell grow into surrounding tissues and destroy them. Boundaries of the tumor at its infiltrating growth is not clearly defined. Infiltrating growth tumors are fast. It is characteristic of immature malignant tumor. So here we see 2 examples on this picture: in situ carcinoma and invasive carcinoma. In situ, it means that it didn't invite into the basal plate. So here we see in the red color malignant cells which didn't broke the basal lamina, and another part of this picture we have invasive carcinoma, and we see that these red cells, which described malignant tumor, broke down the basal lamina and it invasive in the surrounding tissue, so it can metastasize into surrounding tissues. If we talk about most of the cancers, it have some period of time when it's in situ carcinoma, and we can destroy it without risk of recidive of malignant growth. Second type of growth is expansive growth. With expansive growth, the tumor grows out of itself, pushing back surrounding tissue. The expansive growth of the tumor is slow. It is characteristic for mature benign tumors. I must say, what does it mean, immature and mature cells? You know that all cells in our body have some specific features, and mature cells, it means it looks like some specific tissue cells. So they grow and they have specific shape, specific parts of the cell. specific chemical compounds into, and they can produce specific compounds. They looks like normal tissue. As a lipoma, as I say earlier, because it consists from the adipose tissue, lipid tissue. It looks like normal cells from adipose tissues, but it's to match them into one place. And immature cells, it means they didn't look like any other cell in our body, and it means that energy metabolism and growth rate, metastasis and invasion are high in these cells. So when we talk about expensive growth type, on which picture we see the expensive growth type? So who from you thinks that on the left picture you're right? Because on the right picture we have see invasive growth. Oppositional growth type. Oppositional growth of the tumor is due to a neoplastic transformation of normal cells into tumor cells, which is observed in tumor field. On this picture we have thyroid, which can be which can become a tumor in the different parts of this organ, endocrine organ, because some time ago it can have experience of radiation, or X-ray radiation, or some another oncogenic agent which act on this endocrine organ, and so another part of this organ become malignant in the different type in the different parts of this organ. We have on and multicentric types of growth. So multicentric types of growth, it's oppositional type of growth too, and unicentric, it means like on the left picture we have growth of the tumor on the one part of the organ. And fifth, growth by relation to the whole organs. We have two major types of relation to the whole organ: endophytic growth. It means infiltrating tumor growth deep into the whole organ. In this case, the tumor from the surface of the mucous membrane, for example stomach, bladder, bronchi, and intestine, can be almost invisible. And second, exophytic growth. The expansive growth of a tumor into the organ cavities, for example the stomach, bladder, bronchi, and intestines. The tumor in this case can fill a significant part of the cavity, connecting with the wall of its leg. Background diseases. Disease that can cause cancer. Example: congenital shortening of the esophagus, hyperthermia, hernia, gastritis, and prostatitis. I take this picture for you because I wanna that you understand what doesn't mean precancer. Precancer and non-inflammatory local growth of monomorphic young epithelium. We have here on the picture different types of the different stages of development of cancer, and on the first picture we have precancer. It's the cell polyp, which means it doesn't malignant, but with the With time, it will be traumatized and it become malignant. Or not obviously, it can be not traumatized, it can have experience of exposure of another teratogen, and it will be malignant tumor. Precancer is divided to obligate precancer and facultative or optional precancer. Obligate precancer related to a genetic factor always progress to cancer. An example: xeroderma pigmentosum, familial adenomatosis polyposis, and bone dermatosis. Here on the picture we see xeroderma pigmentosum. And facultative or optional precancer, non-related to a genetic factor, rarely progress to cancer. Example: cervical extropion or cervical erosion, keratoacanthoma, atrophic gastritis. Here we see keratoacanthoma on the face of the elderly patient. Morphological terminology: metaplasia, dysplasia, and anaplasia. Metaplasia is a transformation of one differentiated cell type to another differentiated cell type. Dysplasia is an abnormal growth of development of cells, microscopic scale, and of organs, macroscopic scale, and of the abnormal histology or anatomical structure, presumably resulting from such growth. Anaplasia is a condition of cells with poor cellular differentiation, losing the morphological characteristics of mature cells and their orientation with respect to each other and endothelial cells. Carcinoma in situ is a group of abnormal cells. These abnormal cells grow in their normal place, thus in situ mean from Latin in its place. For example, carcinoma in situ of the skin, also called Bowen's disease, is the accumulation of dysplasic epidermal cells within the epidermis only, that has failed to penetrate into the deeper dermis. For this reason, carcinoma in situ will usually not form a tumor. Rather, the lesion is flat in the skin, cervix, etc., or follows the existing architecture of the organ, in the breast, lung, etc. Exceptions include carcinoma in situ of the colon, polyps, the bladder, pre-invasive papillary cancer, or the breast, ductal carcinoma in situ, or lobular carcinoma in situ, does not extend beyond the basal membrane.